Okay, uh, very good afternoon. So, in continuation with our last class, we'll continue the same a non-conventional or renewable source of energy. In that, another types of renewable sources are a tar sand and oil shell energy. A tar sand and oil shell energy. Okay, so this tar sand or a oil sand, it is also called as a oil sand or a tar sand. So it is an expression used to describe the porous substance, a deposited or impregnated with a heavy viscous oil, and it is called as a bitumina. Okay, so in the picture you can able to see. So the person who is hold this small amount of a slurry type substance. So this substance is called as a bitumina, or it is also called as a tar sand or oil sand, and it is always in the it is not a solid or neither a liquid. It is in the semi solid state, so it is directly obtained on the earth crust, and it's a raw material. From this we are going to extract the some organic substances or organic materials, and those organic materials again burned or used for any other uh, useful energy conversions, like we can convert electric energy or any other useful form of energies. And in the picture, the person who is holding some slurry type substance is called as or it indicates that core sand. And this the process which convert, or the process which are used to convert this tar sand to producing synthetic crude oil, or from this oil sand. So it is having again some continuous process. Through that process we can able to convert those raw materials into a final useful product. The first uh, so this is what the tar sand or oil sand mining. So these are the deposits which are on the earth crust, and here mining means we already know that we just dig the material or a substance on the earth crust and transport from one place to another place where it convert to one form to another form. And these are the some typical pictures. Okay, and these substances mainly contain hydrocarbons. So hydrocarbons means it is an while combustion of hydrocarbons will forms the heat energy along with some byproducts. Okay. And this is what the a typical layout or a picture which describes the conversion of raw material into a final product. So here the sand, which are the oil sand or an tar sand, which is obtained by the mining, okay, is, from the mining or a surface, are first passed through a conditioning drum. Okay, so here first that passed through a conditioning drum. Okay, so first that tar sand or oil sand take into the conditioning drum. It's a chamber. It's a closed chamber. Conditioning drum means it is a closed chamber where that oil sand is mixed with water and steam and caustic soda. It is mixed with a tar sand or an oil sand, then water, then a steam, then caustic soda. It's a mixture of in a closed chamber, that is called conditioning drum. Okay. What happens in that in the conditioning drum? It is forms the slurry. While combining all these substances together, it forms the a slurry. A slurry is formed. Then the slurry is passed into a separation tank. Next, it is passed into a separation tank where a coarse sand settled at the bottom. In the tank, the core particle of that sand are settled in the bottom, and a fourth of bitumina, means the bitumina is, and the water with a fine material matter forms on the top. Okay, so in that separation chamber, what happens? The core particles are heavy particles are settled on the bottom, and in the top, on the top of that chamber, there is a bitumina and the water and the fine materials are collected on the top. and we can easily separate the bottom slurry type heavy particles are separated, and the top whatever the particles or matters present in it is get separated. The fourth next that separated the top that materials, minerals as well as bitumina is next moving into the next stage, and it is diluted with naphtha. It is diluted with a substance called naphtha, and next it is moving into the a centrifugal action. Next, that entire mixture is moving into the centrifugal action. As a result of this centrifugal action, a fine material or a matters and the water is removed. The fine material as well as water get removed from that entire mixture. And after this, the naphtha, again the naphtha also we have to recycled, or we have to remove and recovered and recycled. The same naphtha again used for the next cycle. It is recovered and recycled, and the bitumina is obtained. From this process, the bitumina is clearly obtained. Then the obtained bitumina is subjected to hydroprocessing and desulfurization. Means we have to remove the sulfur content, and next it is moving into the hydroprocessing, means increasing the hydrocarbon content in that process or in that material, and it is become finally it is become a crude oil or synthetic crude oil. And this synthetic crude oil we can use for a combustion process, and while combustion it will liberates a lot of amount of energy, and that energy we can take for a next stage of conversion, like that heat energy get converted into steam, and the steam is into the turbines, and the turbines will rotate with the help of steam, and it will generate the electric energy. This is the next stage of conversion process. The first stage of conversion is directly that oil sand from the mining taken into the conditioning drum or a closed chamber. In that it is mixed with water, steam and caustic soda, and it forms the slurry. Then the slurry is moving into the next section called separate tank. In that separate tank, it forms the two layers, bottom layer and the top layer. Bottom layer having an core particles, heavy core particles, and the top layer having an this bitumina along with the fine particles and water molecules. Next, once that separated the top layer, again moving into the next section. In that we added some particles of naphtha. So naphtha if you had, and it will get separated, and that naphtha and this mixture is moving into the centrifugal action, centrifugal chamber, where the centrifugal action will taking place. Okay, and because of that centrifugal action, it will separate the water particles, it will separate the fine particles, and it will separate the bitumina as well as it will separate the naphtha. Okay, again naphtha is recovered and recycled for the next cycle. And this bitumina, again that process, that bitumina whatever the crude oil, it is also called as a crude oil or a bitumina, it is moving into the next section where it will hydro processing as well as desulfurization. Means it will removing the sulfur content in that, and it will increase the hydrocarbon content. Then it is become a synthetic crude oil. It is called as a synthetic crude oil. It is not a natural crude oil. Natural crude oil is a petroleum product, but it is a synthetic man-made crude oil. Again, this crude oil next section means the next conversion is this crude oil into the heat energy by heat energy means what? By chemical reaction called combustion. If you go through the combustion, it will forms the lot of heat. That heat taken into the next section called turbine section, where the water get converted and it forms the steam, and that steam is will into the turbines, and it will use to run the turbines and also produce the electricity. It is one set. Or else we can take this heat into the some any useful form of substances where it will change the phase, and we can take into the again set of electric generations. So this is how we convert a tar sand or oil sand into the crude oil. Then that crude oil is used to convert that one form to another form of energy. Okay, so this is also a renewable source of energy. This coal sand, it is plentifully available on the earth crust, abundantly available on the earth crust, and it is inexhaustible, and it is, if you use continuously, it won't exhaust. So in that second one is oil shell. So the first one is tar sand. It is in the semi-liquid, sorry, semi-solid state. Okay, neither solid nor liquid. But the next one is a oil shell. Oil shell is a perfect rock shape. The oil shells are a sedimentary rocks. They are also called as a sedimentary rocks which are present in the earth crust, and it refers to the a fine structured rock mixed with a solid organic materials. Means it is having an some rock, along with that rock it is having an some organic materials. That organic material we call it as a, we can call it that substance as a kerogen. Okay, the first one is in the tar sand, bitumina we extracted, that is the organic material. But here oil shell we extract kerogen. It is not kerosene, it is a kerogen. It is called kerogen. The kerogen is a organic material which is present in the sedimentary rocks. Okay, and here these rocks, again there is a mining process. It need a mining means extracting the rocks directly from on the top of the earth crust and moving into the where the conversion is taking place. First these rocks are crushed. These rocks are crushed and it can be burned directly. If you want, you can use directly like a coal. Okay, so directly crushed and you can use it as a coal directly. For burning process we can use, but the heating value, it is compared to the coal and petroleum, it is very less. Only it is a 2000 to 17,000 kilojoules per kg. It is very low combustion energy. This energy is nearly equal to the combustion of wood, high quality wood, high grade wood. But when you compare with petroleum, diesel, okay, or any coal combustion, high grade coal combustion, the combustion heat range is nearly 40,000 or 50,000 kilojoules per kg. But here the range of this combustion heating range is 2000 to 17,000 kilojoules per kg. So the efficiency is very less when compared to the coal or any other petroleum products. And this can be used directly for the heating purpose, or else this is also used to for electric generation purpose. So here also same thing. The working principle is first extract these oil shells from the earth crust. Okay, that rocks. Then the rocks are crushed and make a fine powder in the crusher. Then it is resorted. That particles are based on that grain size. We can resort. Then into the crude oil section, we can directly taken into the crude oil section by heating. By heating this oil shell can convert oil. Means this oil shell we can directly use as a coal. One, it's a one method. The another method is we can convert this oil shell as a crude oil, just like a tar sand. Means that oil shell can convert this crude oil, and it done by first crushing. Then that crushed fine particles is heated about 500 degrees centigrade. Means more than 500 degrees centigrade we can heat that oil shell in absence of air. Okay, in absence of air, if you heat that, and there is an process will taking place, and it that process is called as pyrolysis process, and which converts that whatever the oil shell, the particles into kerosene. And this kerosene is called as a oil, crude oil. Again we know that that crude oil uh, is same, we can use directly for the burning process, or else we can taken into the a section called electric generation, where the electric generation needs a turbines, it needs a generators, and this combustion, and it need a boilers. So if you use boilers, that boiler, this fuel, that kerosene as an, we can use it as a fuel. And while combustion, then in the boiler the water is get converted into steam, and that steam is taken into the turbine section, where it converts that heat energy into a mechanical energy. Then in the mechanical energy in the generator, it converts mechanical energy to electric energy. Then that electric energy is taken in for any other useful purpose, or else our day-to-day life use. So this is how we can convert that oil shells and tar sand or oil sand into our useful form. So these are also a renewable source. We just need to a conversion process, because they are in the raw form. Then the raw form has to convert to crude oil for the effective use. If you don't want, you can directly use as a raw form. And come to the demerits of this oil sands and this process is, okay, the use of oil shells is an environmental degradation. Means if you continuously use, it will start degradation continuously. We can take that materials from the earth crust and associate it with the surfaces, okay, and convert. And after conversion, there is a waste material. That waste material disposal is an another set of problem, another demerits of this type of process. The waste product which is obtained by this process, the disposal of that waste product is an another headache, or it's a major problem. And again, it need a lot of sedimentary rocks or tar sand for conversion of a small amount of crude oil. It need heavy raw material. And another set of drawback is it's a large amount of energy is consumed. Because if you want, you can directly use, no problem. But if you want to convert that raw form into an crude oil, again we need a lot of energy for this conversion purpose. Okay, so again it will consume the energy, and it is become a drawback. And also some cost related drawback is also there. And of course, come to the advantages. Of course, it's a renewable source of energy, one thing. And second thing, of course, it produces a small amount of pollution when compared to the coal or any other conventional source of energies. And these are the processes steps: step 1, step 2, step 3, step 4. Through this we can convert. Just I explained how to convert the raw material into a final bituminous product. Okay, first into the drum, then separator, then into the centrifugal action, then separate. You can use it as a bituminous or a crude oil. uh, Disadvantages, I told, it is a high cost. The shells are high cost. The extraction, mining process, then transportation, then conversion. It's a elaborate process, and it is becoming costly. And low net energy means when compared to the other conventional source, it gives a low energy. The efficiency is very low. That's what 2000 to 17,000 kilojoules per kg. And marketplace does not include environmental cost. And land, of course, it need a very huge land, and water pollution and air pollutions. These are the drawbacks. Okay. And next important and the last set of nuclear source of renewable source of energy is a nuclear energy. I think you already heard this nuclear energy. So in your schooling days or in your PUC, you already know what is meant by nuclear energy. What are the process in the nuclear energy or nuclear process? Okay, so nuclear power means it is according to the modern theory. Again, it is becoming based on the some of the theories, a modern theories of atomic structure. It is the theories which are related to the atomic structure, and the matter consists of a minute particles. It consists of a minute particles called atoms. Means this nuclear energy is related to the atoms. Nuclear energy is use of nuclear reactions, and that nuclear reaction is related to the atoms or a minute particles. From this, we are going to extract the energy. That energy is called nuclear energy. Then nuclear energy is converted into useful form of energy is called as electric energy. From the nuclear power plant, we can directly extract the nuclear energy to the electrical energy, and that electrical energy is fulfill our day-to-day life needs. Okay, and this is a picture which clearly describes the nuclear power plant. Nuclear power plant having a lot of subsections like cooling towers, condenser, okay, evaporator sections, steam, okay, and chimneys, and controllers, and nuclear reactor. There are so many subsections. So come to these atoms. represents an enormous concentration of binding energy. These atoms having an enormous amount of energy, and that energy is binded in the atoms. And this controlled or fission or fusion, there are two processes. One process is called fission, means separating. Fusion means combining. Okay, so either separating the particles or combining the particles, like uranium, thorium, plutonium. Okay, so the plutonium is an artificial element, and naturally available elements are uranium and thorium. Okay, so these elements either we can split or we can combine, will produce a lot of energy, and that energy we can convert or we can use for our conversion and produce the electric energy. And this enormous released energy from relative the small amount of material, a very small amount of material means this atoms of uranium or plutonium are very small amount, the mass of amount. And this nuclear fuels makes, and this is called as a nuclear fuels. Okay, nuclear power plant, the nuclear fuels are these atoms. Clear? In the combustion process, the fuels are maybe tar sand, oil sand, coal, petroleum. There may be the fuels. But here in the nuclear power plant, the fuel is nuclear atoms. These atoms is become a nuclear fuels. And they have the lot of source of energy. And the energy is raised completely fusion of 1 kg. If you take an example, if you take example of 1 kg of uranium 235, uranium 235, whatever the amount of energy is released from uranium 235, which is equal to the total energies obtained by a burning of 4500 tons of high grade coal. Means if you burn the 4500 ton of high grade coal, whatever the energy is available, that energy is which is equal to the energy from the uranium 235. Means 1 kg of uranium 235, which is equal to the high grade coal of 4500 high grade coal. Or if you go with a crude oil, okay, I don't want coal, means if you go with a crude oil, then it is 2200 ton. So by combustion of 2200 ton, whatever the energy is liberated, that is equal to the 1 kg of uranium. You just imagine, very small amount of uranium will produce a large amount of energy. Okay, so this is an one effective power plant which can fulfill our day-to-day life of electric requirements. Then the nuclear power having a considerable potentials, we know that. And in countries like so many countries are there. Okay, in our India also we are having a lot of nuclear power plants. uh, and there are three important systems are considered for nuclear generations. There are three important uh, there are three important systems considered for nuclear power generation. First one is based on the natural uranium. I told uranium and thorium are the naturally available, and plutonium are the synthetic one, or it is the artificial one. So based on the natural uranium yielding power. And the second employs the fast breeder reactor, a fast breeder reactor using plutonium and depleted uranium. And the third one is by the fast breeder of thorium and converting into the uranium. The first one is directly uranium, okay, yielding of uranium. And the second one, it is of uh, a fast breeder reactor with a plutonium and depletion of uranium. And the third one is fast breeder reactor with a thorium and converting it into the uranium. So these are the three systems we can use to extract the fuels. And the first method is alone has been commercialized in India. Means we are using the first method and in India, and the other method may be taken some of the more times larger than the first. And in India, ore is a poor in uranium content. So in India, whatever the ore is obtained, that ore is having a poor uranium content, means 0.025 to 0.067 percentage. and with an 235 megawatt plant requires about 23 ton of uranium besides initial charge of 60 ton. Means if you want to generate a 235 megawatt, it need a 23 ton of uranium besides initial charges of 60 ton. So this much of amount of uranium is required. So in Indian reservoirs, the uranium ore is an estimated about 50,000 ton of an oxide, and thorium is 450,000 ton of thoria. So ore is thoria. From that thoria we can extract thorium. Okay. So these are the major drawbacks, and in our Indian ore having a poor content of uranium. Okay. Come to the important two processes in the nuclear reaction. There are two processes. We already know that it is a fission as well as fusion reaction. The first one is a breeder reactor and nuclear fusion. So breeder means it's a fission, and the nuclear fusion means adding. The first, we go with the first set of process. So it is called as a breeder reactor. So in order to understand the working of breeder reactor, it is necessary to understand the fission reaction. Fission means splitting action. Naturally occurring uranium contains three isotopes. One is uranium 234, uranium 235, uranium 238. The relative percentage of these isotopes are uranium 234, which is equal to 0.006 percentage, and uranium 235, which is 0.711 percentage, and uranium 238, it is 99.23 percentage of these isotopes, and only uranium 235 undergoes a spontaneous fission when subjected to bombardment by a slow neutrons. Bombardments energizing the atoms is called bombardment. And it is in the fact that only naturally occurring materials, visible materials. The breaking of uranium 235, the breaking of uranium 235 when subjected to a neutron, and the release of a large amount of energy as a heat, which is equal to 8.2 into 10 raised to 7 kilojoules per gram. Only per gram. If you split the per gram material, it will liberate 8.2 into 10 raised to 7 kilojoules of that much of energy is liberated by uranium 235. The neutrons are slowed down by moderator. Means this entire process is taking place in the controlled section, the nuclear reactor. Okay, and we are using the controller and moderator to control these processes. And there are setting of a controlled chain reactions. They are chain reactions, means once the atoms start splitting, it continuously start splitting the atoms, and continuously it will liberates the energies, and these entire process should be controlled, should takes place in a controlled manner. Although the uranium 238 is not fissile material, and it is very fertile material, and it can be converted by neutron bombardment and into the fissile material. And plutonium 238 is again another material we can use for this process, same like a just like a conversion of uranium 233. And it will see in the neutron generation in the fusion reaction. In the picture we can able to see, this is what this schematic picture which represents the nuclear power plant. Okay, entire nuclear power plant, and the first section is a nuclear reactor. It is a nuclear reactor, and this nuclear reactor, it is with a control rod. The one thing is a control rod. Okay, and in the nuclear reactor there is a core. Okay, and this is a closed chamber. In this closed chamber there is a control rod with a core, and here there is a bombardment of atoms will takes place, means the splitting of atoms, uranium or thorium or plutonium atoms. And while splitting that, it will liberates a lot of enormous amount of energy, and that energy is again used for the next section. It is called a, it is also called as a evaporator section, or it is also called as a exchanger, heat exchanger. Okay, so this the first whatever this core and the control rod having a chamber, that chamber is connect with the coils, and those coils are in turn connect with uh, the water or any other substances, because the coil, inside the coil there is a large amount of heat is flowing through the coil, and that heat is surrounded by a water, and that water gain the heat through this chamber. Okay, then it will convert that heat. Okay, that heat, whatever the heat is there, that heat through the coil, that heat is having a higher heat, that higher heat start moving into the lower body, means water is having a lower heat. So by absorbing heat from this coil, that water get converted into a steam. Okay, and again that coil, the substance there in the coil is again back into the same core chamber. Okay, in the core chamber again it will gain the heat by the fusion reaction, and again into the this water section. It is a continuous process, and it is a closed one, and it is entirely controlled by control rods as well as pressure vessels, means the pressure and the heat is controlled. Again, once the water is get heated, and it will convert the phase, it converts into a steam, then that steam is moving into the next section called turbine section. You can see these are the turbines. That steam is having a high pressure and high temperature. That high pressure and high temperature steam is projecting on the turbines, and it will start rotate the turbines. Okay, and it will done some work, and after doing work, again this steam is moving into the condenser section. It is moving into the condenser section. Okay, where in the condenser section again it changed the phase from gaseous to liquid. Okay, it is become a water, and again that the same water with the help of pump again moving into the same heat exchanger. Okay, and again heat exchanger, it is contact with the coils and gain the heat again into the turbine. Again also is a continuous process. In the first set of continuous process, the substance will exchange the heat, and second set of process, the water is used and it will also gain the heat and it will do some work. It is also continuous process. And come to the turbines, because of the steam, it takes place some work, and that work will rotate the turbines, and the rotate turbines connect with the generator, and in the generator, because of this mechanical action, it will convert that mechanical action to the electric energy. And once the electric energy is generated, then it is taken into the electric grids. Okay, where we can store and we can transmission for our day-to-day life. And again in the condenser, we need a condenser system, and this water again this in the condenser chamber, that what steam and the water is connect with the some sort of coils, and these coils are again cool water. Okay, that is what the cooling tower. From the cooling tower, okay, the cold water or the normal water is from the maybe in the sum or in the river, we can take that water, and that water again into the condenser, where in the condenser the normal water having a low temperature and the steam having a high temperature, and there is a rejection of heat from the steam to the water. And once that water absorbs the energy from the steam again into the towers, cooling towers, where the heat is rejected into the atmosphere. Okay, and in the cooling towers, this hot water interact with the atmospheric air. So atmospheric air will absorb these heat, and that water will reject heat into the atmosphere. Okay, so these are the cooling towers. Again that water maybe we can recycle or we can dump into the river. So there are three cycles. First cycle, that substance in the reactor. Second cycle, water and steam cycle, continuous cycle. And in the third, there is a cooling tower. There are three set of process we need. From this, we can generate the fusion reaction to the electric energy. This is what the working principle of nuclear power plant. So here the control rods are there, pressure vessels, the water pump, water, pumping of water, condenser, evaporator, turbines, then electric generator, transmission lines, warm water, cold water, and the cooling tower. These are the main devices or equipments need for successful run of nuclear power plant. So this is a one set. So one method. So another method, it's called as a fusion. Fusion means it is an uh, first one is fusion means splitting. Fusion means joining. So in the nuclear fission, the energy is released by joining a very light atoms. The reaction of intersect, and it involves the fusioning of heavy isotopes of hydrogen. So it means here we are using hydrogen atoms and deuterium and tritanium, deuterium D and tritanium T. These are the two materials we are using for this fusion reactions. And it is not like a splitting of atoms, it is joining of atoms. And by joining or splitting of atoms, it will liberates the energy. And this adding or joining of this atoms will having some series of reactions like D plus D means D means it is an deuterium plus deuterium will give rise to T. T means it is an tritium. Tritium plus P plus 4.0 megawatt. Second reaction D plus D, which gives to He3 plus N plus 3.2. Again, third stage of reaction D plus T, deuterium plus titanium, will give the He4 plus N plus 17.6 megawatt. And D plus He plus 3 means these are the whatever the substances by adding it will produce the byproducts. Again, the byproduct is the main product. If we add, this is a continuous adding process. Will use the He4 plus P plus P means neutron and protons plus 18.3 megawatt. And totally, but total of these reactions will the combination of 6 deuterium will give rise to 2 E4, okay, and 2 proton, 2 neutron plus 43.1 ME. That much of heat is liberated. Okay, so deuterium occurs naturally in the earth crust. It is in seawater. Deuterium is naturally occur in the seawater, and it is estimated that the fusion of all these deuterium, the fusion of whatever the fusion, deuterium available on the seawater, if you add all fusion of this deuterium in just 1 cubic meter of seawater, would yield a 12.10 raised to 9 kilojoules. You just imagine how much of energy is raised. Just a 1 cubic seawater of the deuterium will produce us 12.10 raised to minus 9 kilojoule. Okay, the development of nuclear fusion reactors are the attained by requiring high temperature. Means this process will need a high temperature. The adding of course, the splitting of atoms, it will liberates the energy. But here, adding of atoms, before that, we have to raise the temperature of that atom. That raising the temperature need a energy which is equal to some billions of degree centigrades. Means it need a very high heat energy for bombardment of these atoms. Then only they will start adding the particles, adding the atoms. Then it will liberates energy. Okay, the researchers began conducting the solve this problem. Means that preheating process broadly into the two consumption directions. One is by the magnetic confinement and laser induction process, either by laser induced fusion process or by magnetic confinement. These are the two processes. Based on this, we can increase the temperature and we can start the adding the particles. Again, the same by adding the particles, which is takes place in the same nuclear reactor, and this adding it liberates a lot of energy, and that energy is taken into the heat exchanger where these coils will take the heat energy and interact with the water, and that water gain the energy from this coil, and it will start change the phase from liquid to gaseous in the form of steam. Again, that steam taken into the turbine where it will rotate. I means will do some necessary work, and that work again converted into electric energy with the help of generator. Then it is connected with the electric grids. Then after doing work, the steam is again back into the condenser where it will reject the heat and again back into the heat exchanger. And this condenser need a continuous supply of cool water from the river, and that cool water from the river will absorb the energy from the steam, and it will moving into the cooling towers. Again, the cooling towers will reject heat to the atmosphere. So this is the same process. The only thing is, in the nuclear reactor, instead of splitting, there is a fusion takes place, and for this fusion reaction, it needs the heat energy, initial heat energy. That initial heat energy, either by with the help of the two process I told, the magnetic confinement or laser induced fusion process. So clear? So these are the two processes. And come to the limitations or drawback. uh, so there are some limitations of this nuclear energy. So mainly the capital cost, the initial investment is very high. Okay, nuclear reactor initial cost is very high. First thing, the nuclear reactor power plant, and the limited availability of the raw materials, the uranium or plutonium. There is a limited supply of material. There is another set of drawback, and difficulty associated with the disposal. After doing that work, the disposal of that splitted atoms which are from the nuclear reactor, it's a very headache, because it produces a radioactive waste. They are radioactive waste, and these radioactive waste are very highly hazardous to the animals as well as human beings. So disposal needs uh, highly sophisticated devices for a proper disposal of this nuclear waste. And advantages, of course, from this we can generate an enormous amount of energy. Okay, and we can continuous supply of energy, we get that. But the thing is, only drawback is the disposal, and it produces a air pollution. Okay, and applications, come to the applications. There are so many applications in our India. The nuclear power plant, nearly 400 megawatt, 2 into 200. So in the Maharashtra we can see applications, and uranium reservoirs in the small scale also, where in India also, Bihar installed, and in the Maharashtra and in the Rajasthan. These are all based on the uranium based nuclear power plants, and about 5,000 to 10,000 megawatt nuclear capacity. Okay, I will show you one video how that conversion will takes place. So this is what the nuclear power plant. This is the nuclear power plant station. This is the cooling towers. This is the chambers. This is the power generation. It's a containment building. It's called as a containment building. It's a reinforced concrete. It is completely built by reinforced concrete, because there is no heat exchange between the atmosphere and this inside. It's a cooling tower. Reactor. This is what the nuclear reactor. Okay, this is the pressure vessels. I told nuclear reactor. These are the control rods. In the reactor, there is a nuclear reaction taking place, either fusion or fusion reactions. These are the control rods, and it's very thick rods, and there is the pressure vessels, and these are coils, and the fuel pellets. Yes, it's a thermal energy which keeps the nuclear reaction continuous. And heat exchanger and the pump. And the heat exchanger, what happens that whatever the heat generated in the reactor, taken in by the into the heat exchanger, where that heat uh, will from the coil to the water. Okay. And next, that heat into the steam turbines, where the steam turbines will operate because of the steam, and it will generate the necessary electric energy. Okay. So heat exchanger. Then the steam into the turbines, where it will rotate. Low pressure turbines will rotate because of the steam, and it will generate the energy, and this is what the generator, where it converts mechanical to electric energy. Okay, generators. Then it is again river, and these are the cooling towers, and it is condenser. Okay, this is what the nuclear power generation.